In this lesson, I'll talk about the web services layer. I mentioned this briefly in one of the first lessons about the layered architectural pattern. When I talked about the web service layer that would allow, for example, a service department at an auto dealership to request warranty reimbursement authorization from an auto manufacturer. Remember that? A web service layer provided an API of methods that are consumed by client applications across network boundaries, including firewalls. And it would allow organizations around the world to use this application and all share the same back-end domain services, application services, maybe would be a better way to state that. But at any rate, a web services layer can sit at several places in an application's layered architecture. In the scenario I described, it sits between the presentation layer and the application services layer. So this allows chunky, coarse-grained methods in the application services layer to be exposed over the network, whether that network's an intranet, an extranet, or the internet at large. A presentation layer, typically a native client application, but it doesn't necessarily have to be. It could be a web services, a website application. It would make calls into the application services layer by making calls against the web services layer. The purpose of this layer is to serialize and deserialize the requests to and from the presentation layer and the application services layer, transforming the simple data types or the POCOs or the generic collections of POCOs or entire object graphs into XML for the purpose of transmitting over a network boundary and then deserializing them back so that they can be used in .NET. All right, so there are several technologies in the .NET world that allow you to create a web services layer for your layered architecture. The first is Windows Communication Foundation, and the second is the ASP.NET Web API. It's a newer technology. There's one more. It's called WCF Data Services. However, in my opinion, this one has limited usage because it's more about exposing data in a very open way and probably doesn't fit into most enterprise architectures that seek to hide, not freely expose data to the entire world. A fourth option is something called WCF RIA Data Services, but it's so tightly coupled to Silverlight that I'm definitely not recommending you learn it unless you have to support an old application that utilized it. Now, I only make this point about these Microsoft-specific APIs because they really do you a favor and hide the complexities of building a web services layer. Because in order to make all of this work and work regardless of which technologies and vendors are implementing the various parts of this architecture, you're relying on a series of standards, web services standards. Nobody owns these standards. They're created and agreed upon by a group of individuals who band together for a limited time for the purpose of deciding how a given technology should work. These individuals represent the interests of their particular employer, typically, as well as the industry in general. At the end of months or years of discussion and debate and trial and error, they put their recommendations into a specification. It goes through an approval process. There's a way to version the document as it goes through this process as well. And it's generally at some point agreed upon by all members. It might even potentially be endorsed or recognized by other standards bodies. But at any rate, to enable data transfer using web services, there's probably like 24 of these web service standards, and they address all the tiny details of how services will be located and described, how messages will be sent and received and secured, how exceptions will be reported back and forth, and so on. They're usually described under this umbrella of the WS star, which means WS all of the above. And I'm going to talk about a couple of them, at least at a high level, but without standards, you wouldn't be able to allow a Java client or an iOS client to call methods and retrieve data from our web services layer created with .NET. Instead, the entire stack of technologies from top to bottom would have to be from a single vendor, limiting the usefulness and the adoption of our application. Now, the most challenging aspect about learning about web services and the web services layer and even service-oriented architecture, in my opinion, is first of all, three things. First of all, understanding all the terminology involved, because there's a ton of new terminology that's added to the mix whenever we're talking about web services. Secondly, understanding the issues that you face whenever you introduce a web services layer into your architecture. And then third, understanding the role and the purpose of each standard in ensuring disparate platforms and technologies are able to communicate with each other. Honestly, the only way that all these concepts will become second nature to you is if you take the time to work through some WCF and ASP.NET Web API examples. But at this point, that's not really our focus. We're simply trying to understand conceptually the purpose and the role of a web services layer at a high level. So let's do that. Let's talk about the role of a web services layer. And basically it's this: to simply expose a set of services. Think of a service in this context as simply a method that can be called over a network. So yeah, it's still a method, it still has input parameters, it's still going to return values back, it's still going to have a body that does some work. It may even call into other methods that are hosted at the same place it is, or call off to additional web services, but essentially it's just a method that can be called over the network, and because of the framework around it, it knows how to transmit messages back and forth. All right. So typically this method is going to expose application functionality. Either it's going to expose functionality that was created in the domain layer, or more likely the application services layer. I suppose you could have methods that expose data from the persistence layer if you really wanted to, although I'm not sure that's the sort of thing I would do personally. I guess it depends, and hopefully as we go through this, you'll begin to understand why it may not make so much sense. But yeah, you could do that too, I guess. In fact, that's really the purpose of WCF data services. All right. So, but when I think of a web services layer, I'm really thinking of a way to, first of all, distribute my architecture, and then secondly, to decouple my architecture. So this is both a conceptual and a physical notion. I can distribute pieces of my architecture around the globe. Wherever there's data that I need to consume, I could implement a web service method that allows me to consume that data. It also decouples my architecture, so many different applications could be served by a single web service. That service isn't necessarily tied just to my application now. It could be used by multiple applications. So let me give you another example here. Perhaps I work for a large organization, multiple offices around the globe. The Washington, D.C. office manages customer information, so it can serve that information to client applications. Perhaps my Los Angeles office manages sales and opportunity information, so it can serve that information to client applications. So now I'm creating an application, I come in later, and I want to marry current customers with new opportunities somehow, some way, okay? Well, I can consume those services for my application. And another developer in the same organization could consume those services for a different type of application. A partner organization, some partner to our company, could, outside of the firewall, could gain access to certain portions of that information as well. So the way I see it, the role of a web services layer is to expose domain layer functionality through a set of well-defined web services, each service having well-defined endpoints. An endpoint is simply like a URL, a port number like port 80 or port 443 or something like that, a given transport technology like HTTP or TCP, and so on. Services also have well-defined contracts, which means that it defines somewhere what operations they support, the message format, including the input form parameters and the output values, as well as what message encoding, so how will the messages be bundled together in XML, what format will they be in, and maybe other security related details as well. A service layer would also be responsible for serializing and deserializing domain entities or data transfer objects for transmission, and map service endpoints to methods defined in the domain layer. Again, I would probably leave that to the application services layer. So, it's more chunky in nature and less chatty. We'll talk about that in a moment. It would be also responsible for light validation logic. Any complex validation logic, I would guess, would be delegated to the domain layer. So just making sure types that there's actually are correct, that there's actually data, and that values aren't null, and so forth. All right. So in some ways, it's useful to think of the delineation between a web services layer and the domain layer in the same way that you would delineate between the responsibilities of the presentation layer and the domain layer. The web services layer is merely another means of presenting the data. It's just presenting the data to a client that's a software system instead of the eyes of a human user. Okay? In my opinion, the role of a web services layer in your architecture is relatively easy to conceptualize and to design. I mean, you've already designed the domain layer, and you've probably already designed a application services layer. This is merely a public extension of that. So in my mind, the challenge with introducing a web services layer into your design is the complexity of the implementation. There's so many little tiny details, things like from a software developer perspective, how do you actually develop a web service? How do you host a web service? If you're consuming a web service, how do you interface with it? How do you learn about the methods, the services that it exposes, the operations that it exposes, and how it expects to communicate back and forth? How do you configure the service to use a particular network protocol? How do you configure the service to format the messages so that it can be consumed by different platforms, like a Java client and an iOS client? And how do you secure the body of a message? So all these tiny little implementation details. For me, that's where the challenge comes in. There's probably a dozen other little issues like this as well. And it's tempting to talk about all these things right now, but that'll have to wait until a series of videos specifically on either the WCF or the ASP.NET Web API. Right now, I want to take a look at the application architecture guide. If you take a look on page 116, I believe it is, and 117, you'll see that there's a diagram here that you see on screen right now. And it talks about the two different types of components that are inside of a services layer. There's service interfaces and message types. And I think the best way to illustrate this is actually to go and create a new WCF project. So in the Visual C# templates, I'm going to choose WCF and make sure to choose a WCF service application. I don't care what the name is, because all I really want to do is just point out the template and what it does for you. But it makes a differentiation between the two. You can think of service interfaces as the methods that will be called, and message types as the data that will be communicated back and forth between the client and the web service. So if you take a look at the Solution Explorer for our new WCF application, you can see that we have a interface called iService1, and then also an implementation of that interface called Service1. If you take a look in the iService1 that we're looking at right now, let me blow this out to like 130. All right, there we go. A little bit easier to see now. You can see an example of both a service interface and message types. So here you're defining what methods would be available in this web service, and here you're defining what type of data will get sent back and forth. And the trick here is that when you use the term interface, it's unfortunately overloaded. We're using the term interface in two contexts here. It could be a little bit confusing. So right now we're looking at a C# interface, and the only reason that they add an interface to this project for you by default is so that you can create multiple implementations of this web service. You might create one implementation of the web service designed to be used on an internal network, and then you might create another version of this web service to be used externally. The way that you protect the web service, the way it communicates, you set all of that using attributes, just like you see these attributes here that are specific to WCF. So you can control how the messages are formatted, what type of security they use. You can control how they're exposed and implemented on Windows Activation Services or IIS services or whatever the case might be. All right. So that's one sense in which we're using the term interface. It allows us to make sure that these different implementations of our web service, if we need them, will be the same no matter what. All right. So that's one way that we're using the term interface. The second way which we're using the term interface is to mean a contract. In fact, you can see the attributes of this service contract defined here, that the service has two operations. And so there's a service contract and an operation contract. And so in essence, there are two methods that can be called at this web service. All right. And so anything that inherits from this iService1, namely Service1, will automatically get these attributes applied to it. But at any rate, that's an example of the contract, the interface from that perspective. Notice that this simple operation, this simple web method, it allows us to pass in an integer and get back a string, while the second version has a more complicated input and output parameter, or result type, I guess you could say, of type composite type. All right, so it takes an instance of composite type and it returns an instance of composite type. Again, just some example code. Here's where composite type is being defined. And so when we talk about message types, this is the definition of a message type. It's basically a class, and we say this class has a special purpose. We want it to be a data contract, and here are the members, the public properties, I guess you can say, of this contract. And it has two, something called bool value and something called string value. Now we can see how these methods and these message types are used in an actual implementation by looking at the service1.svc.cs. Here we get, again, service1 implements the iService1 interface, and then the getData method takes an integer and returns a string, and all you're doing is just appending this integer value to this hard-coded string. And then in this composite type, you take a look at the Boolean value, and if it's true, then we'll just append the term suffix. And why did they give you this? It's just a little cheat sheet, because you're probably not creating WCF services every day. This gets you up and running very quickly. But again, this is probably the easiest way for me to illustrate what the two types or the two pieces of a web service entail. When the application architecture guide talks about service interfaces, so here's two service interfaces, get data and get data using data contract, and then message types, specifically this composite type, this integer value, this string, and so on. Okay? All right. So since we've already referenced the Microsoft Application Architecture Guide, I might point out that it does a nice job to also talk about common design considerations and issues with web services layer. So let me address some of those. The first design consideration that I find useful in the guide is the scope of web services. It talks about chatty versus chunky communication. I think I've used that term already when we were talking about application services layer. We're going to talk about it at length in the next lesson as well. But when a client makes a call to a web service, that call is potentially expensive. Not only is there an expense in serializing and deserializing the object, like this composite type, for example, into a message format like XML. Not only is it expensive encoding the message, so for example in character encoding that can be transported across the internet, I don't know, or encoding for security purposes, but the most expensive of all operations is sending the request across the network. That's especially expensive when the network is the internet, not just a private network. The call could be coming from across the globe. So we want to minimize the number of calls from the client to the service. And this demands that we design our web services to be chunky, coarse-grained in scope. We want to minimize the chatter back and forth between the client and the service. And to do this, we have to keep this as one of the foremost design considerations. The second design consideration that I find useful is on that same page I believe 117, 118, thereabouts, that you should make no assumptions about the client or the consumer of the web services you build. And I take this to mean that you should do nothing to preclude different types of clients. The operation should be atomic in nature, not requiring a lot of setup or preconditions before they can be called. In other words, you should be thinking about stateless operations as much as possible. And there are some other considerations that'll sound familiar to you, things like encapsulate the implementation details, separate concerns. These are all the ideas that we've discussed before, but they're being applied directly to this new layer of the architecture. Many of the specific design issues are addressed by WCF, so I'm not going to take the time to cover all of them that they mention in the guide. In a series specifically about Windows Communication Foundation, we'll see how these issues impact our implementation decisions. All right, so let me wrap up. At a high level, a web services layer introduces flexibility into your architecture, allowing you to extend your domain logic, your business logic layers functionality to clients across network boundaries as well as clients on other platforms. It accomplishes this through a set of contracts and web standards. Now, we've talked about all of the layers that we're going to talk about. It's time to talk about the interaction between these layers, and I've addressed it here, and I want to make sure that I give it a little bit more attention than just sporadically throughout this series like I've done up to this point. I want to make sure I cover all the bases. So we'll talk about how layers interact in the next two lessons. See you there. Thank you.